So this video, we're going to start a new series on working with SDL2 and COBOL. So this is not specifically a COBOL video series. This is working with SDL and COBOL. So I will assume you have maybe a little bit of COBOL knowledge, or it's not very hard to follow. It's pretty self-explanatory, but this is not specifically a COBOL training video. So there's COBOL. I'm using GNU COBOL specifically. So if you want to follow along, that's the version of COBOL. I'm also using NeoVim. You don't need to use this, but I'm just going to show specifically because I had to use the tree sitter COBOL, and this is a third-party one. This is not built into tree sitter, so I had to add this to get syntax highlighting for COBOL in NeoVim. In VS Code, you could probably just type in COBOL, and there might be, but I think there's 2 or 3 available. I'm not really sure. And then we'll be working with SDL2. So, and to follow this series, you're going to need the GitHub Programming Rainbow Beginner's Guide to SDL2 in COBOL. So this is the repository. This is actually the entire, this will be all the videos. It's all done here already. So right away, let's just look real quick at this. For me to get syntax highlighting, I am using, like I said, I'm using NVChad specifically version of NeoVim, but it's not, you can use whatever version you like. So to get it working on NVChad, I needed to add basically this right here, just this third-party tree sitter COBOL, and I just put it in the custom. I'm in the custom folder. If you use an NVChad and the plugins.lua, and just add that entry right there. And I also added this line right here to set the .cbl file type for COBOL, but that was about it. I'm going to exit this now. So let's go here. So to work with this, you're going to need Make. We're going to use Make in this video. So you're going to need Make, you're going to need GNU COBOL, you're going to need SDL. So if you're on Linux or something, you know, on Windows, maybe you should not be. But if you're on Linux or another system, it's going to look something like this. Like you're going to need GNU COBOL down here, Make, SDL2, SDL2 image, SDL2 TTF, and SDL2 mixer. That's for the entire project. That's what you'll need. I already have these installed. And you'll need to clone the repository. So it'll be git clone, and it'll be, you can just grab it straight off the website here, the URL. And it'll be that Programming Rainbow Beginner's Guide to SDL2 in COBOL. You just copy that, git clone in whatever directory you want to put it in. It's going to make a folder or a file, however you want to say it, directory, Beginner's Guide to SDL2 in COBOL. So I'm going to do that. I'm not sure if I already have it. I don't. Okay. All right. So working with COBOL, in the other videos, and we can do it real quick on here, but I kind of want to just explain a Makefile. So let's just build the project real quick, and we'll see what the end result of this entire series is going to be called. So we'll be working in, let's see here, let me just close this, get into source folder. Every one of these video files, it just has a main. They're all single file. The whole thing is just going to be a single file, and I'm just building on it from each video. But let's look at this one here. And we're not going to cover all this. This is just what it looks like with the syntax highlighting, and I'm going to build it real quick. To build that, I'm just going to say make. Yeah, just make. Should work. Okay. And that has built it. Now you'll notice I have a whole bunch of flags. We'll talk about these, but basically I'm trying to make the compiler pretty strict. I want it to be the safest version of the code I can do. So the compiler is going to be fairly strict here. I'm turning on a lot of warnings, and I'm making my warnings as errors. So let's check out the program. I'm going to run the program, but I'm going to pause the music right after launching it, so you don't have to listen to the music the whole time. I'm just going to pause it immediately. I'm just going to use make run.
COBOL.
I think that
COBOL.
pauses the music.
COBOL. 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 SDL. COBOL.
Okay, and we can move the character around.
SDL.
And we can change the color.
SDL. COBOL. COBOL.
So this is just kind of a demo program that's going to show all the working bits of SDL that you would need to make a game. So, like I said, normally I would just compile this from the command line, but because I want to use all these extra flags, so if we wanted to compile this, we could just say COBC, and we're going to need -x and -o. And normally in COBOL you wouldn't need this next step, but this F static call, this is because I'm going to be calling C libraries directly. So because of this, we need the, and if you want to turn off warnings, you can do -w, but we don't need that. I'm going to use this F static call. And then after that, that's basically all you need. And then you just need the source, which is in the source folder. It's called main COBOL. And then the output file, which we can just call demo, is what I called it here. And this is just how you could compile it. So if you don't want to use the Makefile or anything like that, this is just the basic command. I'm just throwing in all these extra that you see up here, all these extra warnings to make it stricter. And I like to just use the Makefile just to say make, rebuild, make run, make clean. It's very easy to use, but I just want to show the command line. So that is COBC, like COBOL compiler, -x. I think that's for executable. I'm not sure what the O is for. The static is for, because we're calling C library code directly from COBOL. So we need that. And then we have our source, and then we have our output. So that's how we would run it. And I did not put in the libraries that you need as well. So you need -l SDL2, -l SDL2 image, -l SDL2 TTF, and -l SDL2 mixer. There we go. That one ran. So that would be at the end of the whole project with everything included. That's the kind of command line that you would run. These -ls, this stands for where the library is. If you're running some weird, strange setup like, say, Windows, I'm not sure what you're going to need to do there. Whatever you need to do for normally compiling of C or C++ with SDL2 libraries, that's what you're going to need. So if you're using package config or SDL2 config, or however you want to do it, I think that we're SDL2 config. If you're doing something like this, you could put that. You can put these flags in exactly the way that you would put in if you were using GCC or something like that. It would be the exact same. So however you find your libraries, that's the way you do it. I don't believe it needs to find header files. It's kind of strange. COBOL just kind of directly calls C libraries. So there is no including headers. There's pretty much nothing. You just make a call to a function, but you need to put the linker needs to know where to get those functions from. So I kind of want to go through and explain my Makefile first. I just wanted to show you how to build it without the Makefile, or to at least know the basics so that if you need to modify it for your system, you'll understand what's going on with this Makefile. So let's look at the Makefile. So it is not a very complicated Makefile. This is just to help me automate things, but I'm calling what I'm compiling, I'm calling it demo. And I'm having it in the source folder, but I'm using this $equals. That means I can override this. So, and I'll show you that in a minute here, but I can basically type this in before make and have it equal and say video 1, and I can compile what's in video 1 instead of what's in source folder. And as well, if you're running a different COBOL compiler, I put a on there too, so that you could override that, though I'm not sure if any other COBOL version will work besides GNU. I just threw it there just in case. And then this is the compiler flags. This is the -x, -o, and then the F static call. And then this is warn all, warn extra, warn additional, turn warnings into errors, and then even more warnings. All the warnings I believe I could find. And I believe I have warn error repeated here. That's warn errors right there as well. So these are all the compiler flags, and then we have our library for the linker, SDL2, SDL2 image, SDL2 mixer, TTF. Those are pretty much the only things that we're dealing with. And so our target is called demo. So this is a rule. The rule is, now I forget the terminology for the makefile, but basically this is a rule. This is a recipe. It's saying to make target, I need this, and then this is the recipe to build it. This is a prerequisite, and this is the recipe. So here's the rule to build target. I need the recipe, which is I need something in the source folder, which is source, and I'm just using main.cbl, and I'm using my compiler, which is up here. COBOL compiler is here. That is the variable that expands to what is there. Here's the variable that expands to all these flags. And then this right here, this $ and the right arrow key stands for the first from these prerequisites. It's the first item of the prerequisites. Then we have our libraries, our libs, sorry, kind of lib flags. And then we have our -O for the output. And then this right here, the $ ampersand, or not ampersand, at symbol, whatever this symbol is called here. This one refers to the actual rule name, the target right here. That is in this one, target. So this thing is saying the output is going to be whatever this name is, which is demo. That's -O, that's the output. This is the libs. This is right here, the source file. This is the compiler flags up here. So I hope that all makes sense. That is a rule to make to actually make something. Then down below here, we have these phony rules. These phony rules are rules that don't actually build something, they automate something. So all just builds the target. That's the default. If I just say make, it's just gonna build the target. If I say make clean, it's not gonna build the target. Instead, it's gonna, this is for Linux, it's not gonna work on Windows, but it's gonna remove the target file, which was that demo. If one is there. If one's not there, it's going to remove it no matter what. It's going to try to remove it. There will be no error if it's not there. It's fine. Run again. Again, you'll see this $ in greater than symbol that was up here. Remember, I said it was for the first prerequisite. On this one, run, the rule is the dummy, and the prerequisite is something that needs to happen before this can happen, and that's the target. The target needs to be built first. And then this is just .. and the target name, which is demo. This just runs it. And then rebuild is another dummy that just says, hey, first I need you to clean. I need you to run this clean. And then I need you to do this all, which is just build the target. So this makes it where I can say make clean, make rebuild, make run, all that stuff. It makes it really simple, automated. Hopefully that's a good explanation. Let's kind of show that off. So like I said, I can redirect. So we have this source directory that was that had a question mark and an equal sign. So we could do it like this. So if I wanted to rebuild, if I make sure I'm not using an old binary, and then run it, and I want to run the one, say, in the first folder, that would be video 1 folder, which is actually just a very simple kind of hello world project. It doesn't even open a window. I would just do that. There we go. And that's it. It tried to clean it, tried to remove the old one. It built it, then it ran it. And this was the output of that project, the very first project that we will be working with today. This is what it's building. And if I wanted to build, say, the one that I can draw a background, so that should be like the 4th video maybe. And there we go. We have our background drawn. But that allows me to build any of the ones I want. And it's nice. I don't have to do that. I can just say, If I want to clean, I can say make clean, and it just deletes the demo that was there, the demo file. Yeah, so that's make. If you don't know how to use make, that's it's pretty easy. It's the same for C, C++, everything else. It just automates your build process. So that being covered, I'm going to kind of use this make in this video series. So we're going to move on now to actually building a COBOL file. So I'm going to get rid of all these others. And I'm gonna remove this one here. That's like the final project. And I'm going to take the one from, well, we're just going to build it. So we'll make a new one, and I'll just call it main CBL. There we go. Now this is empty. So this one, we're just going to build the most basic, kind of like I said, hello world, but I am going to show a couple little things going on in it. So the very first thing we need, the spacing, I'm going to always tab in past the traditional way where it should be the numbers that take up the first 6, I think, characters. Let's find out. Yeah, right there. Right there. And then this can be a, yeah. So if I was commenting out, you know, this is a comment. So this thing right here, I forgot how many spaces it is. This on a punch card would be where the number is. So it's 1, 2, 3, 4, 5, 6, 7. So I think asterisk is at 7. So everything I'm going to do is going to be at 8, unless I'm specifically putting a comment in that's at 7. So I'm always going to be indenting into 8 for this, and that should be the way that normal COBOL programs run, but I don't know if it's strictly followed. If you want to comment something out, this asterisk must be right here. I believe it's at the 7th. It must be there. You'll know if you put it too far, it'll be like this. That's my syntax highlighter actually telling me it's wrong now. And if I bring it in, it's still wrong. It's wrong no matter what, unless it's specifically at that, I think, 7th line. And my code will never start on this line. So let's just put some more code here. It'll start after it. So the first thing we need is the identification division. A lot of things are going to be capitalized in this as well. Hope I spelled that right. I'm a really good speller. Yeah, looks good. So we got the identification division, and this is a sentence, so we need a period after it. And I'm going to give it the name now, the program ID. And I'm going to call this demo. Okay, so that is the very first thing we need. And you'll see how this is indented slightly more than this. I'm not going to use this for anything. It's used for a couple different things. One of them is for commenting, but it's not going to be anything we're using in the code ever. So that spot right there, when I tab in, I'm always going to tab one more past that because I'm not using that spot right there. Okay, now we're going down to the data division. Don't want to be in this line. There we go. And file section. Nothing's going to be in this file section. Or, yeah. And the working storage section is where we're going to be putting variables and things. Working storage section. So in here, I'm going to make a variable. So like I said, this is not a COBOL, like how, I'm not explaining everything. I'm expecting that you maybe have followed a COBOL tutorial before this one. So I'm kind of glossing over some of these things, I'm just lightly touching on them, but I'm going to be using a mixture of like pick clauses and different ones that are more that are more suited to working with C. So, but for here, we'll just use a pick clause. And that's the type of what this variable is holding, the type of information it's holding. And also this variable is not going to have any it's not like in like say C, you would have a struct where you have a top level item and then members. This is not going to be that. This is just an atomic variable. It's its own standalone variable. So it's going to be at 77. I could use 1 or 77. 77 basically says that there's not going to be any sub members of this. This variable is the variable. And I'm going to call this, I'm not going to give it capitals because these are variables I'm making up. I'm not sure what's the proper way, like if you're allowed to use whatever when you want. I kind of want to follow the tradition here with all the capitals and how it's all set up, but for my own, I don't think there's an issue with giving it a lowercase. And here's the pick clause. And I'm just want 20 characters. I'm going to give space for 20 characters, and they're X, I believe, is alphanumeric. I could put X, 20 times, but I'm just going to say there's 20 X's. And I'm going to give it a default value. And I'm going to say hello standard. This will make sense in a minute. And there's our period at the end of our sentence. And now I'm going to make another one of these. And this as well as pick. And initial value. Okay. Now that this period is not for the string that's in this. The period is for this actual sentence of the COBOL program. These are called sentences. Okay, moving on. We're gonna the highlighter. It wants me to indent differently, but I don't want it like that. So I'm gonna move on to the procedure division. This is where the where all your logic will go. This is how you're kind of working out the logic of your program. Procedure division, and I'm going to have a main procedure. I do want this to be down a line. Main procedure. So in this procedure, why don't we just start with just printing out something, To print something out, we just use display. Display, and the thing that I want to print out, which is hello, not capital, hello st. And now I could just do this like this, right? But if I compile this, because of all the extra warnings I've put on the compiler, it's going to complain. So you don't strictly need anything else, but my compiler is going to say, hey, you should have an end display here. So I already know the compiler is probably going to complain about this. We'll test it though in a minute. So there's the end display. So after this, why don't we just let the program shut down? We'll do a stop run. And then we want to be down there. Okay. And we're going to say end program demo. Okay, do I have punctuation on everything, I hope? Okay, that should be everything that we need for this program to run. And I'm just going to leave this up here. You can see they're all indented a little bit more than that. Okay, so I'm going to save this. And we are in source folder. So I'll just show you without the make. And it's in source, and we don't need this right now. That should be everything that we need right there. Yeah, that was it. So this should print something out when we run it. Okay, it says hello standard. Okay, now I'm gonna remove this end display here. Let's just see the normal compiler if it complains. It doesn't complain. Now I'm going to do a make rebuild, and this is using my Makefile now, and it did not like it. See that? So my Makefile has all those very strict, but it is saying, if you look here, it says display statement not terminated by end display, and it's a warning that I've turned into an error. Okay, and it didn't even let me compile it with that. So we're going to see that we're going to be using quite strict rules, because since I'm not a professional COBOL programmer, I would just prefer to have the strictest rules in place so I don't make mistakes that I might not even realize I'm making, and it would just kind of steer me in the right direction. So end display. And now let's try the make again. Okay, and that ran. We can just do a make. We don't need a rebuild now, but it's fine. I do that a lot. We could just say make run, and again we get hello standard. Okay, so let's play around with this a little bit more. We can perform, we can make other procedures and then perform those. And the reason why I have two strings here is because I want to show two different ways to output, because this will be needed in our SDL program, the outputting two different ways. So let's, after this stop run here, because I do want the main procedure not to, the code will fall through. They call it waterfall. So if I have the main procedure here and then I have more procedures below it, it's kind of like a switch statement in C or other languages where if you don't put a break, it just falls through and it keeps running code after it. So if I put multiple procedures down here, kind of like functions or something, not really functions, but they're a little bit like that. If when main gets done running, even if I'm calling them in main, when main finishes, if I don't have the stop run here, it's just going to keep going and keep running those other, well, we'll see that here in a second too. So we'll just show that off. So I want a new, I'm going to make one called print std out. So that is the name of our new procedure. And all this is going to do is display, well, it's just going to do this right here. So just copy that. Okay. And let's make another one. I'm going to put an exit on this. And I think that's just for readability purposes. It's saying that this is the end of this procedure, although I don't believe it stops anything from moving through, but we'll test that. So let's make another one, say print std error. And we'll put an exit on this as well. So we have two of these now, and then we have our end program. So up here, where we were printing it before, we can call one of these procedures. We can say perform, and then we'll say the one we want to perform, which is the print std out. Did I spell it out? Yeah, I did. Okay, there we go. And there's the period. And we can say perform print std error. So we have these two here, and I don't have the stop run here, so we'll see. I'll put an exit here. We'll see if it falls through. I'll say rebuild, so we know our source is new. Okay, it's not defined. So I've spelled std. Yeah, I spelled it wrong. Okay, spelling problem. Okay, yeah, see it says hello standard, hello standard, hello standard, hello, all right. And this should have said error right here on this one. So that was a bug on my fault, my end. So yeah, the exit is, I think, for readability, but I'm going to use that. So what we would put here is we'd put stop run. And now we should just see it, hello standard, hello error is what we should see on the output. There we go. Hello standard, hello error. Now, why am I saying standard errors? Well, in Unix, Linux, and I have no idea what's going on in Windows world, but in Unix and Linux and things like that, you have the standard output and the standard error. And you want things printed to standard output sometimes, and you want things printed to standard error. So the way that you would do that is both of these right now are printing to standard output, not standard error. So on this one here, I could say upon std error, and that should now send it not to standard output, but to standard error. Okay, so let's try that again. Okay, now you think maybe I've done something wrong here, but let's check it again. Let's say something like this. Let's say just the standard. So one, we're sending, let's send two, sorry, two. Let's send two to dev null, which is like it's the Unix world of the black hole. You know, you send something there, it just disappears. So one is standard output and two is standard error. So it's going to capture whatever's on standard error and it's going to send it to nowhere. So we're not going to see it. So we should see hello standard and not hello error. Okay, hello standard. I'm just going to remove the recompile bit. There we go. And now if we take one, send standard to the dev null, we should see the error getting through. And there we go. So we should have a way to, let's see here, I always forget how this works. Let's try this one here. No, that's not right. That didn't do what I wanted to do. Maybe it's on the other end. These are one of these things that I forget every time and I have to look it up. Oh, there we go. So that's me sending them both to dev null. Basically, I'm saying send standard error, redirect standard error to standard output. And here I'm saying redirect standard output to dev null. So there's just no output. But anyway, that's just a little thing. So now we know that we can send messages to the normal standard output, and we can send messages to the standard error. So if we have an error that occurred, we can send it there. Let's see what else we got. So yeah, that's that upon std error, because I'm going to use that. And you've seen the comment up here. If we were to move this, it would no longer be a comment right there. And my highlighter highlights it funny now, saying there's something wrong with this. So it does need to be specifically on that line right there. I'm going to delete that. Well, I can just leave it in. Say this is a comment. When I do that, yeah, I'll just leave it. This is a comment. So we have our identification division. We have our program ID there. We also use end program with the same ID right there that does it. We have our data division, our file section. The file section's inside of the data division. The working storage section is also inside data division, and that's where we're going to be putting our variables. And we'll see more complex versions of those in the upcoming videos. And then we have our procedure division. This is our main procedure. This is kind of your main function, what you want to happen. And I'm going to have a stop run at the end of this thing, or some way that the program stops, because the other procedures below it, like I said, it'll fall through. It's like a waterfall. So yeah, so I'll have my procedures below it, but I'm going to have something that's stopping or cleaning up at the end of the main procedure. And there's our print std out. That's our standard output, and this is our standard error printing too. So that is going to wrap it up, I think, for this one. So I hope you enjoyed that. Okay, thanks for watching. Bye.